time, because this is all they get in the question, in this information. You know, what is the ratio of the sun's gravitational force on the moon? So sun, moon. So we've got the sun, the force of the sun, moon. And then you have the force of the earth, moon, right? So you're just going to use Newton's law of gravitation. F equals gmm over r squared. But then what you've got to do, this takes some time, you have to look up what is the mass of the sun and what is the mass of the moon. And then the radius is the distance between the earth or the sun and the moon, which is really the same as the sun and the earth. Really, this r will be the sun, earth, because you're not going to find it, because the moon is changing, and the moon is so close to the earth from the perspective of the sun that you're going to find the distance from the sun to the earth. And I found that to be, by the way, it's 1.5 times 10 to the 8th meters. Is that right? No, 8. No, it's 12. That's kilometers. And then what you'll have to do is calculate this number. And then for the Earth moon, you have to do the same thing. You're going to have to look up the mass of the Earth and the mass of the sun. The mass of the Earth, for all, I'll write it out if you care. I found them, just looked up the internet. Mass of the Earth is 5.97 times 10 to the 24th. The mass of the sun is 1.99 times 10 to the 30th. And the mass of the moon is 7.34 times 10 to the 22nd. Those are all in kilograms, by the way. And then for the Earth to the moon, again, it's just the same equation, F equals g mm over r squared. Now, if you really want to think about this, you can actually, you're doing a ratio. So if you think about it for a moment, if you do the ratio, this is equals, by the way, the g's cancel. And that's going to save you a little bit of work, so you don't have to put the g in the equation, and then you can get the answer. But it's just kind of a keeping track of all your numbers. That's how you solve the problem. And by the way, the ratio is very small. I think I get 1.68 as the answer. So even though you've got these big numbers with all these exponents, it's just 1.68. And that makes sense if you think about it. The Earth to the moon, since the Earth and the moon are so close together, the Earth has a gravitational effect on it, but then the sun does too. But it's a function, again, of the fact that the sun, even though it's much, much more massive, it's so much further away.